Why hello lovely humans, Jen Foxbot here. Welcome to another edition of Math Mondays, da 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 da, yeah! Alright, so glad you were able to join me. We're actually almost done with Algebra 2, woohoo! So in that light, if there are any questions that you still have about Algebra 2 topics, or algebra in general, if there's anything that I skipped over, or didn't dive into as much as you'd like, please let me know. And of course, I'm going to be moving on to different types of math topics. So if let me know what the things are that you want to learn, because that's the whole point, right? To focus on teaching how to speak the language of math to do the things that you want to do. All right. So in this episode, we are going to dive into sequences and series, or basically looking at patterns and asking how can we write an equation to represent that pattern. So a lot of higher level math work with sequences and series involves some memorization of different types of formulas, and that's totally fine because, like I've said before, we want to build on top of the work that other folks have done to make our lives easier. So you can derive all of those equations within, there's a bunch of different series equations that you can memorize so that, for example, if you have like x plus y to the nth power, this is called a binomial series expansion, there's an equation you can memorize that generalizes expansion of this form. And it's a lot easier to memorize that equation than to derive this by hand. So where it makes sense, memorization works. For this episode, I'm confident that you can go forth and memorize whatever you want. So for this episode, we're going to focus on understanding how to represent a pattern in math with an equation, and also how to read the expressions that represent different types of mathematical sequences and series. So we'll dive into this nice little Greek symbol, which is the summation sign, in the second part. In the first part, we're going to focus on building up an equation from a pattern. So let's start simple. So here's one that we've all definitely seen. I'm going to use an ellipses, a dot, 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 to represent the fact that it keeps on going. And so in this case, we can look at it and our brains are like, oh, I got it. You just add 2 to the previous number and you're all good to go. Cool, no problem. Why do we need an equation for this? What? Well, let's say that we needed to find the 241st number in this pattern. And you're like, I do not want to write down 240 terms. No, thank you. And that would be a really good point. In math, we want to save time and be lazy. And so if we can write an equation to generalize this pattern, then we don't actually have to write it down. We can just plug in the term that we're looking for, or the number term that we're looking for, and then calculate the answer using our equation. So cool, that's the goal. So first, we need to know a couple of things about how we're going to define our pattern. So the first thing is that we want to note that each of these are terms within our pattern. And to represent those terms, I'm going to use standard notation and say that this is the first term by representing it with an A and a subscript of 1. So then you would say that this is your second term, this is your third term, and so on. And the total number of terms in your sequence can be represented by the nth term, where this is the letter N, and N represents the total number of terms. I'm going to use this in 2 ways, actually. And so it can represent the total number of terms. And I'm going to pick a different letter. I'm going to contradict myself already. And so what I'm going to say is that I is is a particular term of interest. So we'll just say that it is some term. So for example, I could say, if I was interested in the 241st term, I could say that a to the I would be a to the 241. Okay, so we can think of I as our index, and if you've done some coding, you'll be like, ah, yes, index. I am familiar with I. I am familiar with I. That's funny. There's got to be some joke in there. I'll leave it to y'all to figure that out. Okay, so in this equation, we start with the number 2. And so I actually want to point this out because it's a lot different than starting with 0. If we started with 0, we wouldn't really have to add anything to start with. But since we start with 2, we have to account for that in our pattern. Because we can't just say that to get to the second term, you just multiply by 2. You actually have to start with the first term. You're like, wait, what? I don't get that. So basically, whatever term we're looking for, we have to add this in because that's where we're starting. We're not starting at 0. But that's okay. So that just means we add, that looks like an I, but that is a 1. We just add this first term right off the bat, and then that takes care of our starting point. And this would work regardless of where you're starting. If I wanted to use the same pattern, but I started it at 102 instead, then that's fine, because in this case, we would just add 102 instead of 2, and we'll get the same result. That's why equations are nice, is because we can talk about things broadly and apply it to a lot of different scenarios, which makes our equation much more powerful. Okay, so now we have to figure out, okay, so how do we generalize this pattern? Well, let's start by looking at how the pattern works. When n equals 1, a1 equals 2. When n is 2, a to the 2 is 4. When n is 3, a 3 is 6. And let's just do one more with my crooked handwriting. A to the 4 is 8. It's an equal sign. Okay, so note that we already have to add 2. So if we look at this first term and we say, when n is 1, we need to get 2. So if we already added 2, that's it. We want whatever else is in this second part of the equation to cancel out. So right off the bat, that tells me that we want to start with something like n minus 1. And I'm just going to leave that there for now. This isn't quite done, but we're building up an equation. So I want to have this as a placeholder. And then we use that to double check. So when n is 1, let's check our equation. When n equals 1, we have 2 plus, it's going to give us 2 minus, or sorry, our n is 1. 1 minus 1, which is 0, that'll cancel. Ta-da! We're good to go. So it works for this, this term. What about when n equals 2? Okay, well, when an equals 2, can you all see it up here? Yeah. Okay, so when n is 2, a2 equals 2 plus, I'll draw a line there, 2 plus 2 minus 1, oopsies, equals 2 plus 1 equals 3. Oh, foo! That didn't work. So we are 1 off. So we need to add something else to this to make it work. Okay, well, since we are 1 off, I note that if we multiply this parentheses by a 2, we will get what we're looking for. So now let's retry that equation. So with this 2 out front, if we're looking for the second term, then we have 2 plus 2 times 2 minus 1, which is 1. 2 plus 2 is 4. Ta-da! All right. We will check that off. Okay. Now what about n equals 3? Does our equation still hold? Okay. A3 equals 2 plus 2 times 3 minus 1 is going to give me a 2. 2 plus 4 equals 6. Ooh, I think our pattern might be good, or our equation might be good. And then lastly, let's check A4. So we have 2 plus 2 times 4 minus 1 is 3. We get 2 plus 6 equals 8. All right, cool, huh? So now that we have checked 4 different cases, we know that our equation is suitable for our pattern. Yay! And now we can use our equation to ask what is the 241st term of this sequence. So a of 241 equals 2, our first term, plus 2 times 241 minus 1, which is going to be 240. 2 plus 480 equals 482. Ta-da! That was way faster than if we had written out all of these terms. And also we saved so much space. Yay! Okay, so I'm already at 11 minutes here. So what I'm going to do is I'm going to break this into 2 parts. So I'll pause here. Let me know if you have any questions about building up an equation from a sequence. I would challenge you to try some harder examples, maybe like 3, 6, 9, 12, those sorts of things, and see if you can write equations to fit those patterns. Definitely always check at least 3 examples. Cool. So we're going to pause, and in part 2, we will dive into kind of doing the opposite. So taking an equation and figuring out what the sequence is. So check out part 2. Yeah.